So I went to a store and I purchased the wheel that everybody in short course thought was the best wheel you could buy. So I purchased that wheel, I had the wheel 3D scanned, and then I ran a bunch of stress analysis on it and developed a whole bunch of different testing procedures to benchmark values. In 1 week, designed a wheel 5 pounds lighter, twice as strong.
Welcome to the HPO Tune-In podcast. I'm Andre, your host, and in this episode, we're joined by Joe Scarbo from Scarbo Performance and Scarbo Vintage. For some context, Joe was instrumental in the design and development of the Huna Pig. However, we've covered the Huna Pig in a reasonable amount of detail in a number of other podcasts, so we're diving in a slightly different direction here because he's also involved in one of his own pet projects, which is the development of the SV Rover. This is, in his own words, the world's first off-road hypertruck. And that might sound like a bold claim, but when you see this vehicle, it kind of all makes sense. Joe's leveraged his extensive knowledge of both engineering and design, as well as 3D modeling and CAD, to produce something that really is a work of art. He's also overcome some pretty large design hurdles, such as how do you engineer 30 inches of wheel travel into this particular project. The truck is also set up to support both internal combustion and electric motors, so there's a lot of flexibility here depending on what the client specifically wants. Before we jump into our chat, for those who are new to the Tune-In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Joe. Thanks for joining us today. This is one that I have been looking forward to for a while. And as always, let's start by finding out about your background and how you got involved in cars.
Yeah, so my interest in cars really came from my dad. My dad was always interested in cars and RC stuff long before I was ever around. So by the time I became 3 or 4 years old, I was already playing with RC cars and helping my dad build stuff in the garage. So that's definitely where it started, definitely what I'm passionate about. I'm still to this day passionate about RC models. So as I got older, it was important to my dad to kind of put me into racing along with being able to build and tinker on mechanical stuff. So at the age of 6, he bought an Emic 100cc go-kart that I was able to start practicing in. And over the next roughly 7 years or so, lots more go-karts came and we raced all over the country and had a good run at the go-kart racing scene. So
Okay. Did that then developed into racing actual tin top cars of it later on?
It eventually did. There were a number of wrecks, unfortunately, that my mom witnessed when I was young. And at some point, she saw the writing on the wall and said that she really didn't want me pursuing a career in motorsport as a driver. So that kind of ended my go-kart career around the age of 13. And for the next few years, I still continued building RC stuff and playing around with motorized things. And then when it came time to go to college, I decided I would go to school to get a degree in mechanical engineering, which meant that if I couldn't race cars, I could at least design and build them.
Sure. Just coming back to the safety aspect, kind of having gone through the early days of racing karts myself, and I ended up tangled up in what was at the time a pretty gnarly accident. I got the kart rolled over on top of me. I don't know, it's probably about 12 or 13 at that time, which is actually still to this day giving me a sort of a lower back pain that I can't get rid of. I kind of sort of argue though, once you graduate to a tin top car, an enclosed car with a proper roll cage around you, a race seat, a 5 or 6 point harness, I don't know. In my mind, the safety aspect climbs way higher than in karts. However, I mean, any form of motorsport obviously comes with its risks.
Without question. And the thing that I always couldn't believe is when you're young, you suit up, you have a helmet, you have a suit, but one thing you don't have in a full-size car typically is a neck brace. So the fact that you put that on every time and you don't really think about it and you just kind of go out there and give it hell is interesting. Not to mention, in all the years that I raced go-karts, we never really saw any bad physical harm. I don't know about you in your.
No, I'd agree. I mean, admittedly, my career in karting was relatively short. I think I probably did it over a period of 3 or 4 years, not long after that accident. I think maybe a bit like you, Mum sort of like, hey, how about we don't do that anymore? That doesn't look very safe. One of the things that I did see a number of times with karting, and it's just an open wheel thing, we see it's just recently happened in Formula One between Verstappen and Hamilton. It only takes a touch of the wheel to wheel and it'll pop one car in the air. And I've seen that happen in karts numerous times. But yeah, again, the Formula One car's got a roll hoop and a halo, and arguably, again, infinitely safer than a kart. But yeah, I digress. Carry on.
Yeah, I left out part of my story. I had a bad wreck, which knocked me unconscious and drugged me down the front straight with my foot between the steering column and the gas tank. And I didn't end up hurt. I got knocked out. I woke up. The chassis was bent. And my dad and I put one corner of the frame on a jack stand and jumped on it to get it square, and I went out and raced in the main. So it wasn't catastrophic in terms of physical harm, but it definitely raises the questions for your parents of what if, So I don't know. Knock on wood, nothing bad really came of that, other than kind of terminating my racing career. But
chances are, though, looking at what you've done with your life up to this point, hey, maybe it was for the best. Let's be honest, there's only 0.001% of people in motorsport actually get to a point where they can actually make a career that pays the bills out of it, and the rest of us just do it for fun and flush $100 notes down the toilet, essentially.
Yeah, and I laugh because years ago when we built that first Formula car, I did end up racing that with SVRA and HMSA, and yes, it's got a roll hoop and proper restraints, but it's an open wheel, 400 horsepower, 1,200 pound thing. Like, that's not the safest thing in the world. But anyway.
All right, so we've decided that Formula One's probably off the agenda, and instead we're going to build Formula One-esque cars with a mechanical engineering degree. So, this probably accounts for maybe half of the guests I have on this podcast. So it's a well-trodden path. Talk to us about how that degree progressed and sort of what you picked up, what you became passionate about through doing that mechanical engineering degree.
Of course. There were a few pivotal things that happened in my life that I think took my ability to design, develop, and build to another level. And I've always wanted to design and build my own stuff from a young age. And it wasn't just go buy a Tamiya RC car and assemble it. It was like, what can I make out of balsa wood and some mechanical parts and, hodgepodge stuff together, or make fan boats out of kickboards, like lots of weird stuff as a child. So when I was in college, I wanted to build my own 4-seat long travel off-road car, but I was working at Home Depot and I didn't have a massive budget to go purchase something like that. So one of the guys that I worked with at Home Depot allowed me to use his garage because my parents said, you're not going to build that at our house. So we started building this chassis on the floor of his garage with like wood shims to basically hold the bottom of the frame square as we welded tubes together. And as I was building that project, I was working at Home Depot one day and a guy came in to rent a tile saw. And as he was about to take the tile saw to his car, he said, there's some stuff I need to go into the store to buy. And I said, well, what's your last name again? Let me pause your rental contract so you're not paying for your rental while you're shopping. And he said his last name was Arciero. which was a name I'd recognized from my years in racing. So I asked him, I said, are you related to the wineries and the racing teams? He goes, yeah. I said, what are you doing here? He goes, well, our race shop is right up the street. And I said, oh, your race shop? I said, what do you do up there? He goes, oh, a ton of stuff. He says, why don't you come up on Monday? So I went up there the following Monday, and he was just starting pre-runner project, and they had a bunch of fabricators and mechanics up there. And I met one of his fabricators, and he basically hired me that day.
Well, straight from Home Depot into the deep end.
Yeah. Working with RCROs, it's like when you work for a family that's owned IndyCar teams and won Baja a number of times, it's like they have the type of people around them that do things at the highest level. So when you see the equipment and the methods that speak for things being done at the highest level, your brain doesn't really know a way other than that from there on out. So
you weren't sort of coming into this at the sort of basement level with a cut-off saw and a MIG welder. You're right in with the top level componentry and production techniques.
Perfect example. When I was building that sand car in my friend's garage, I needed a bunch of threaded tube bosses to thread rod ends in. So I found a piece of tubing that had the OD I needed to sleeve into the tube that I was going to weld to. And it had the ID that was the minor diameter of the thread size for the rod end I was using. So I figured, oh, this is really cool. I can buy a 20-foot stick of this tubing and I can cut it on a chop saw. And then I can put the bosses in a vise and I can thread them by hand with a tab. And for me, that was the most cost-effective solution to get me a bunch of these parts that I needed, because we all have a different budget at a different time in our lives. Now, down the road, if you have a lathe, you're not going to be doing this, right? And all the taps are going to be, it's all going to be on center. You're going to face the end of the tube perfectly. And you would never even consider doing it another way. And it's not that I wasn't being creative or trying to find a solution. It's just you didn't have the opportunity or the equipment.
Well, I think a part of that would also come down to you don't know what you don't know at that stage. If you haven't seen it done another way, well, this makes sense.
Yeah. And at the time, I was 19 years old and trying to build a 4-seat long travel V8 rear engine car from scratch, which was insane. And there were a number of times I'd sit in that garage staring at the transaxle and my rear hubs that I'd built, thinking I have no idea how I'm going to connect these pieces and make everything clear. And this was before I knew how to use CAD. So this was like painter's tape on the floor and thinking through, if the control arm looks like this, then maybe I can get everything to package and link up. And
it's a bold project for a 19-year-old.
It was ridiculous. And the thing that's funny is I towed that car out of there before it was finished. And what's comical is the neighbors around, I would work on that thing all hours of the night with a chop saw making all kinds of noise and drove.
Yeah, it must have been super popular.
Yeah. And the thing that's funny is like a year after I towed it out of there, I towed it back by on a flatbed and one of the neighbors was out. He's like, is that the thing that you were building in the garage? And it was crazy because it was all painted and finished, had aluminum panels on it, and he was laughing to himself, blown away. So
it was going to be my next question. Did you see that project through to fruition? Because often, particularly at that age, the abilities maybe are not quite where they need to be to see a project to the finish line of that magnitude. Because like I say, that's a huge project to undertake.
So I've had that car for a long time. I still own that car. And the thing that's crazy is when you're forced to develop something that you designed and built yourself, the learning curve is so steep. But the things you learn doing that for future cars, you come to find, like, I took maybe 5 trips out to the desert where I would have to have somebody tow my car back to camp because something happened. And after that, you start to figure out all the issues you have. But if you go through that on a number of different scratch-built cars, by the time you do this for the 10th or 20th time, you can go to a track day with a brand new car you just designed and built and run all day long, which is what we did with that first Formula car we built, which was really the first car I'd ever built that we had that much success with. We spent a year designing, building, assembling, and we went and ran at Buttonwillow all day long with essentially no problems.
I mean, that's the dream. Unfortunately, it's rare. It's very rare. Okay, coming back to that 4-seater off-road vehicle that you built, and we're getting a little bit out of order, but it's interesting for me to dive into here in a little bit more detail. At that point, with what I can only assume is essentially no real-world experience in what forces and stresses are going to be involved, And other than obviously what you've been doing with RC cars, how did you sort of decide on what size of components, the design of your control arms, your uprights, maybe even the size of your rod ends to cope with the forces that were going to be involved?
So it was all just gut feeling at the beginning. And when I was sizing the rear control arm tubing, I wanted to run 1.5-inch quarter wall tubing because I needed a 1-inch ID for my rod end bosses. And when I called the material supplier, he says, we don't make that size tubing. So what they did make was 1.25-inch eighth wall tubing, which has the same ID that I needed, but in my brain was substantially less strength than what I was originally thinking. But I figured, that's what's available. That's what I'll build it with. And what I ended up doing is I ended up making that car my senior project in college. And what my professor who was advising me said I had to do if I wanted to use it, he says, you need to do FEA on one of the components. And I was like, oh my gosh, how am I going to do this? I don't know how to use FEA software or anything else. So I modeled the component that I thought had the highest stresses on it, which is the upper control arm in the rear, because the spring is attached to the upper control arm, and that's what suspends the vehicle. And it kind of had like this offset loading to it. So I CAD modeled the upper control arm, and I pressed the button with a few loads on it to simulate. And it took this deformed shape and showed me stresses, and it was like this moment that was like, oh my gosh, this is so cool.
Was this sort of opening your eyes to the window of CAD and the power that it offers, which obviously you're leveraging off heavily these days?
100%. And I'm so happy that my professor forced me to do that, even though I thought it was this like insurmountable thing to do at the time. But it kind of gave me an idea of where the loads were. And then the structural plates that are in that control arm, I kind of extended past the high stress zones. And to this day, fundamentally, no suspension part has failed. No chassis part has failed.
Nailed it.
And that car, it's a 4-seat, rear engine, small block Chevy, all wrecking yard parts. So it's got a wrecking yard 84 Vanagon 4-speed. It's got a small block Chevy, but we've clocked 82 miles per hour on the GPS through some fairly large bumps out by King of the Hammers. So, I mean, the car, it's scary because it was MIG welded in a garage with a 1-ton MIG welder, which is why I tell my kid I'm decommissioning that car because it's a liability at this point. At some point, we're going to, be going way too fast and have a control arm leave.
Yeah. I guess that's also, as a father, it's one thing you're taking that risk yourself, but it's a whole different ball game when you're putting your kids in it. And, if it fails, you'd never be able to forgive yourself.
For sure. And my oldest son loves that car.
I mean, it's kind of cool that you've still got it to this day. A lot of those projects, even if they do get finished, you lose interest along the way, or just kind of gathers dust and gets scrapped or gets sold.
Yeah, it's a very large car, 17 feet long, 102 inches wide, and it's been in my ex-girlfriend's garage because I had nowhere to put it. It's been in my sister's garage. It's been all over the place. I've always found a place to store it one way or another.
Yeah, I mean, that's a hell of a build for a 19-year-old, so all power to you. All right, so let's sort of get a bit of a sense of what happened after college. You graduate with a mechanical engineering degree. Obviously, you're predestined to be working in the automotive industry. What happened next?
So I had mentioned that when I was still in college, working at Home Depot, I got hired by the RC Heroes to be a fabricator and machinist.
Actually, well, let's talk about what your skills at this point with fabrication and machining are. I mean, that's not really sort of going hand in hand with the mechanical engineering degree. Obviously, you've been doing your own projects anyway, but yeah, so where would you say your skill set was at that point?
I think it went from, very quickly, an amateur garage welder to a fabricator and machinist in like 3 months. And I got dumped into a project that the owner would come out and say, hey, by lunchtime, I want to sit in this fucking thing. Like he would say this exactly, right? And I'd be like welding seat tabs on, So it was a lot of pressure and it was fun.
I assume you kind of had a lot of mentors within that business that could guide you and sort of teach you the proper techniques, though?
The thing that's funny is what came out of that one meeting at Home Depot, my entire professional life, like I'll continue the story. So it started as fabricator machinist, And that was for a couple years while I finished my degree. And after we finished the first pre-runner, the owner of that took it to Mexico, and a couple guys in Baja wanted to buy that pre-runner from him. It was one of the first early luxury pre-runners. Full Alcantara interior, satellite radio, refrigerator inside, air conditioning, crazy. But a geyser trophy truck, essentially. And the owner said, I don't want to sell this truck. I just finished it. I absolutely love it. If you want me to build you one, I'll build you one. So he got a contract with T-Force Motorsports in Vista, who was a Toyota trophy truck team, to build 2 more of these trucks. So on this set of trucks, rather than purchasing suspension components from Geyser, I decided I would try to design my own suspension for the 2 trucks we did for T-Force. So another crash course. Now it was like crash course, learn how to fabricate and machine, next crash course, learn how to design suspension components in CAD, have them all laser cut and welded up in a shop.
At this point, what's your level of knowledge with CAD? Obviously, you talked about your experience with FEA back in college, but have you been dabbling more, or is this like in the deep end?
0 to 10, I was a level 2.
Okay, right.
So it was like you sit on SolidWorks and you beat your head against the desk until you make what's in your mind. Anybody that's learned a new CAD software has learned CAD from the beginning, and this was kind of before YouTube.
Yeah. I mean, there's nothing like necessity to kind of drive you to figure it out, I think. But at the same time, with the complicated product software like SolidWorks, there's a learning curve inevitably. Were there any resources that you could leverage at that point to fast track your learning? You just mentioned that YouTube wasn't around. Obviously, these days there's plenty of YouTube tutorials.
Click buttons until you find the thing you're looking for.
Okay, trial and error.
Yeah. So we did the 2 T-Force pre-runners, and as soon we were finishing those trucks the week of my last final exams in school. At that same time, the Arciero family was awarded a contract with Volkswagen North America to do an off-road racing program and the Jetta TDI Cup, which was the Jetta TDI driver selection program. So they hired me to be the in-house engineer for their desert race program.
Wow.
And I started the Monday after my last final exam. And my running joke is that if I wouldn't have passed all of my finals, I wouldn't have been able to start my job on Monday, because I probably would have had to go back to class to
reset something. It's funny how things progress that you just can't see at the time. Like, as you say, that chance meeting at Home Depot, and that's basically drawn the trajectory for the rest of your career so far.
For sure. And then the last thing that really came from that is the general manager of the off-road race program for Volkswagen and the Arcieros. He brought in a mechanical engineer consultant who is a world-renowned race car engineer. He designed some of the UOP Shadow Can-Am cars, the Nissan GTP championship winning cars in the 90s. And he's the type of guy that designs and builds prototypes himself in his garage. He's built his own tube chassis cars personally, and he has a brain for understanding load paths and mechanical design like nobody I've ever met in my life. And his name is Trevor Harris. So very quickly, him and I started working together, and we got along. And he was kind of my sounding board as I was designing the 2008 Volkswagen TDI Touareg. It was a semi-factory backed program. And at the time, Volkswagen and Audi were pushing their clean diesel program. So when we were looking for a diesel to run in that truck, it's like, well, Volkswagen had the V10 twin turbo diesel in the US. That wasn't really a racing engine per se. And when we flew back to Germany to discuss other engine options, there was a European spec Audi Q7 that had a V12 twin turbo diesel. But they also said, well, this isn't really a racing engine, but we're decommissioning all the R10 V12 TDIs. So maybe we can repurpose a few of those engines for your off-road race program. That engine was like a whole next level for me of understanding the legitimacy of Le Mans real motorsport engineering, like structural valve covers that are entirely billet, like
just as far away from production car stuff as you can get.
So that was just another point where I was like, wow, it opened my eyes to how things can be manufactured that are relatively low volume when there is really no cost cap.
Yeah.
So that program ran for about a year and a half. 2008, the economy started to do some weird things, and that program went away. But a connection that I made through that racing program, we were sponsored by KMC Wheels, and the owner of KMC Wheels at that time was in the process of selling KMC to Wheel Pros. And When they were our wheel sponsor, we wanted to have a bespoke wheel made by KMC just for that race truck. I had designed a wheel that KMC made that we ended up using to race on the Touareg. And when the owner of KMC sold KMC to Wheel Pros, he was starting up another wheel company, but he didn't have a designer to design the wheels. So a few guys from KMC were like, well, Joe had designed the wheels for the Touareg. What do you think? So they came to me and asked if I would design the wheels for the new company they were starting, which was Method Race Wheels. And I was blown away and I didn't really know how to respond, but that's what forced me to go start my first business, because I figured if I was doing work as a consultant, I needed a business to be able to make invoices. And
Okay, so this consulting work for Method Wheels, was this not quite a full-time gig? And they didn't want to take you on as a employee, they just wanted consulting work?
To be honest, I never even really asked why.
Yeah, sure. I mean, in a lot of instances, you sort of tend to find as a consultant, well, yes, there are some other aspects that you don't have to deal with as a full-time employee. Generally, you get to kind of charge maybe 1.5 to 2 times what you get paid as a salary for the same amount of work. So, hey, it's not necessarily a bad gig.
The cool part about this is that I was very close with the general manager at Volkswagen. And when they had mentioned that they wanted me to do the design work for their new wheel company, I called my general manager. I said, hey, this is what's on the table. What do you think? I have no idea what to charge. He says, well, you need to charge this. I'm like, you think they'll pay that? And he says, of course, no problem. So I tailored it back maybe 10% because I thought that was like gouging or something. And I told them, okay, it's going to be this much an hour. And they said, okay, no problem at all. And that was a moment where it was 3x. It was 3 times what I was making hourly.
There we go. I guess when you said that was the moment, what you were going to say there is that is the moment that you realized that you should have added that 10% back in. I find it's always easier to negotiate down, very, very hard once someone's accepted a price to then negotiate it back up.
At the end of the day, it was total blessing. When the Volkswagen program went away, obviously I was looking for work. That landed in my lap the following week. And I spent my summer sitting in my kitchen designing wheels and doing stress analysis and building a whole testing procedure. Whenever you do something new, you want to have some kind of frame of reference as to if what you're doing is in the realm of acceptability. So what I did is they said they wanted to go into the short course racing world. So no one knows who I am. So I went to a store and I purchased the wheel that everybody in short course thought was the best wheel you could buy. So I purchased that wheel. I didn't have a 3D scanner at the time, so I had the wheel 3D scanned. And then I ran a bunch of stress analysis on it and developed a whole bunch of different testing procedures to benchmark values. This is a wheel that works. This is what the weight of that wheel is. This is how much load it'll take in this test, how much load it'll take in that test. And then I basically, no joke, in 1 week, designed a wheel 5 pounds lighter, twice as strong.
Wow, that's huge.
And it's just because you start to realize where all the stress concentrations are. It's like little fillets and little radiuses, or if you take a window for spokes, and you cut it out too far into the center of the wheel, it's a massive stress concentration. So you can change fillets and you can change where the knee of the wheel is, and you can do all kinds of crazy things to pull weight out and add strength. That's not super difficult.
To me, just on face value, reducing the weight of the wheel by 5 pounds, albeit obviously would be nice to know what that was as a percentage, it's all relative, but also doubling the strength would suggest that maybe that wheel manufacturer had, I don't know, gotten a little bit lazy. They had a wheel that worked and everyone's buying, so there was no real driving force for them to improve it further. Is that kind of how you see it?
So there is a level of seriousness associated with motorsport in Europe. And there is another level of seriousness associated with motorsport in the US, especially different aspects of motorsport. So you could say IndyCar racing is probably the pinnacle of motorsport in the US. I'm making a generalization. And everything below that has a different level of funding, a different level of engineering, a different level of professionalism sometimes. And off-road racing is somewhere down that list, quite a ways. And it usually is, somebody with a welder and a lathe in a shop that builds something and goes out and tests it and says this is adequate. Not a team of engineers that have mechanical engineering degrees that know suspension geometry, and then they do a geometry layout, and then they do stress analysis on every part. It's a whole different level of engineering. So when you think about the design and development that went into an off-road wheel versus a wheel that was designed in Europe for a vehicle in Dakar, let's say, they're two drastically different levels of engineering and understanding of structure. I think it was 7 or 8 years down the road, Method Race Wheels wanted to go into rally wheel development for Subarus and whatever. Just like before, I requested that they purchase all the wheels on the market that are used in WRC. And I 3D scanned all of them, and I did the same thing as before. I took my same testing procedures, and I built a massive spreadsheet that went through what the strengths were of the various wheels with different load cases. And it took me 4 months to come up with a wheel that matched the strength of the NP rally wheel.
Okay, so that suggests that at this level, they're doing a much better job than the off-road racing where you started.
The mechanical optimization that was done by these companies for these rally wheels was so far beyond. And because I was forced to look at every geometric detail of those wheels to figure out why the stress concentrations weren't there, I learned a ton about where to make cutouts, where to add material, stuff I'd never even considered when I was doing the off-road stuff at the beginning. So it was neat for sure. And they ended up with a neat wheel. I ended up coming up with a wheel that was slightly lighter and slightly stronger than the best wheel I got my hands on.
People listening to this might be sort of questioning, okay, that's cool, you've made a better mousetrap, but how important is that? But the reality is that when we're trying to optimize the suspension operation, anytime we can remove weight out of the unsprung components, it's a massive improvement. It allows essentially the suspension to track undulations in the road much better. There's sort of less weight and inertia there. So this is a really, really big deal, trying to get weight out of a wheel. In that aspect as well, sort of designing a wheel, I would kind of see as kind of 50-50 mechanical design and, making sure those stress concentrations are acceptable and the strength of the wheel is where it needs to be. But the other 50% is kind of more an aesthetic element. In the road car world, we choose a wheel probably primarily because we like the look of it. And I would have thought that those two aspects were there's a disconnect there between what a mechanical engineer is trying to do, which is like just optimize for strength, performance, weight at, the expense perhaps of the aesthetics. So how do you balance those two? Does this sort of come down to the fact that you do have, a creative slant as well, and the aesthetics is something that you can also work with?
That's hard because aesthetics are different for everybody, and everyone has an opinion on what they think is beautiful. So, and even in the wheel world, look how different wheels are. Method Race Wheels, their slogan is stronger, lighter, faster. And that's what they said were their priorities when I was designing. And not saying I don't design ugly things, but I like to think that if something is structurally optimal, it ends up taking a beautiful form.
So form and function go hand in hand, essentially.
Method Race Wheels, since I started with them, has grown so much. And they're they're trying to have wheels that have a lot of different aesthetics, per se. But when I was doing the design work, it was important to me that all the wheels I designed had rotational symmetry, which was based on the lug pattern. So if you had a 6-lug wheel, it would be a 12-spoke wheel. If you had a 5-lug wheel, it would be a 10-spoke wheel. Because if you don't do that and you run the stress analysis, you run up with stress concentrations in certain spots of the wheel where the counterbore is for the lug. That becomes a problem in some areas versus others. And it just means that you end up with a non-optimum scenario.
Yeah, that makes sense.
So, for example, did you go to Method Race Wheels website?
I absolutely did, obviously.
So if you go all auto wheels, for example, and you look at, let's see here. The first wheel they did was called the Standard. It's a 301.
Yep, looking at that right now.
Very basic geometry. And early on, before we actually designed a wheel, we were just trying to come up with what the optimum spoke shape would be. And obviously, if you have a wheel that's constrained on the hub, and then you have a load out at the beads that's trying to tug about on the wheel mounting surface, you end up with a pyramid-shaped thing, where the leverage, as you go towards the center of the wheel, goes up, and therefore the size of the spoke should get larger as it goes towards the hub. That's what all the original method wheels looked like. It wasn't anything fancy.
Just did the job from an engineering perspective.
It was literally, what did we think was the most optimum spoke profile? And that was the wheel.
And again, we'll drop a link to this website that we're just talking about now, because obviously it's a bit difficult with an audio-only podcast to really get this across. So if people want to kind of figure out what we're talking about, there'll be a link that you can follow. I'm just wondering, and we're going kind of really deep down this rabbit hole, but while we're here, I would be thinking that with the current crop of technology that we've got, if you were purely interested in solving the wheel problem for weight and strength, this would be the absolute perfect application for generative design and additive manufacturing. I don't want to know what that would cost, but am I on the right track here?
Yeah, and I think that would be an easy task to set up for generative design because the constraints are fairly simple. I have never personally done it.
I mean, I fear that you could end up with some pretty hideous looking wheels. Generative design is divisive, I think would probably be the term. You kind of either love it or you hate it. But, you know, if you are sort of singled out that you want to solve for these particular properties, then, and I guess that is the ultimate way of doing so.
For sure. And aesthetically, how do I feel about generative design? I think some parts look very elegant. Other parts look overly complicated and strange. But that's my personal opinion.
I think I agree wholeheartedly with that. I think there's maybe places for it that it works and it's suitable, and maybe others where I'm seeing it used for the sake of people using it, and maybe there's not really a great case study for it being used in that particular application. But anyway, as I say, we digress. So you're doing this design work for Method Wheels. Where do we go to from here?
That's what made me start my own business. I was kind of like, each one of these things we've talked about, I was kind of like forced down this road. Yeah, I was asked to do some consulting work. I started my business. The business really operated as just a design consulting company from the start. And as time went on, people that I would consult for would ask to hire me. And I went through this like 3 to 4 year period where somebody I was consulting for would hire me, and I'd work for them for about a year and a half until my consulting business was too busy to have a day job and do my consulting. So then I would just do consulting again. And then another one of my clients would say, hey, we really want to bring you on board. Or they make me a sweet offer to bring me on board. So I would justify it. So then I would go work for them for a year and a half. And then my consulting would get too busy. And then I would I'd quit my job again and then just do consulting. This happened like 3 times. And then it got to the point where I realized that I really should just do my own thing from here on out. And Trevor Harris, I do refer to him as my mentor. He was the consultant for Volkswagen. He had a project he really wanted me to devote a bunch of time developing a new CV joint. So he said, this is going to take at least a year with you working 2 to 3 days a week. I will guarantee you X amount of pay. And that was the perfect step off from the corporate jobs, was to say, okay, I have enough money that's guaranteed to pay my mortgage and my car payment. And then I can spend the other half of the week, doing my own other thing. And that's really how it started. The more stuff that I designed, the more that I wanted to build my own stuff, because then I had control. It's like every time you outsource something or have somebody build it, you're constantly driving back and forth and checking up on it to make sure it's being done properly. And you realize at some point, I really should just be doing this myself. And when I decided to do that, the RCeros provided me with an office at their facility, and I started building components there because they were already tooled up to do it. I didn't have to go buy a bunch of machinery. So my business operated out of the RCeros for, I think, a year and a half. And then I found the commercial spot that you visited. And then I moved, that was 10 years ago, I moved into that building. And when I first was working out of that building, my wife asked me, she said, why do you need so much space? And I was like, I really want to have a lathe and a mill and, the ability to work on some cars. And then the way you saw that building, it's like we had...
You'd outgrown it when we were there. That was 2022, I think, if I remember correctly. But yeah, it was sort of a case of moving 3 cars to get to the car that we actually wanted to do a feature on. And yeah, there was... basically you wouldn't swing a cat in there. So yeah, it was very tight. But I mean, I think as the case of a business like your own, you kind of never really have enough space. And it's very easy to kind of grow into the space and expand. So you kind of become self-limited, I guess, by the space you have to work from. Before we carry on, I'm just interested with the discussion we've already had about consulting versus working for a salaried position. And obviously you mentioned, the initial consulting work was a 3x increase in your salary. So most people would think, yeah, there's a no-brainer. I'm assuming, though, there's a whole bunch of downsides that come with that. Having a full-time position for a company and just working as an employee, it's pretty safe. You know that your paycheck's going to be X every week. You've got benefits usually, which are pretty important in the US, and you just turn up to work and do what you're told, and if you do a good job, you'll probably have a job next week. Whereas there's a lot more that goes into consulting in terms of finding the work in the first place. Granted, you kind of got that handed to you on a platter, but then the invoicing and all of the other sort of business elements that go along with running a consulting business. I'm interested could you have a perspective on sort of how hard that was coming from being an employee?
When it was small, I enjoyed it a lot more because I was more in control. Yes, there are trade-offs. I'll answer your question first. The thing, depending on what you choose to do when you start your own business, there's X amount of risk associated with you doing work for somebody else. Number one, you hope that the work that you're doing efficiently with the use of your own time to where you're able to bill out for all of your hours. Because if you do a bunch of design work that your customer doesn't like or isn't good work, they either want you to give them their money back or work on it until it's proper. That can turn into a very painful scenario. And like I said, depending on what type of work you're doing, it makes that drastically different. If somebody comes to you and says, I want you to design a wheel, you can give them an idea of how many hours it takes to do that. You design the wheel, hopefully they like it, they pay the invoice, good to go. As we started to build our own projects and people came to us with full car projects, you have the discussion with the client, what are you looking for? You have to ballpark how many hours you think it's going to take and what materials it's going to take to execute that project. The issue with one-off car builds is that the scope changes so drastically through those projects, which correspondingly the budget changes. And you have to make sure, I didn't do this early on and it made car builds really painful for myself and for my clients. And it's not because either of us were necessarily doing anything wrong. Arguably, maybe I did something wrong, not saying that this could grow to 2 to 4 times the budget that we were originally discussing. But it's just kind of the nature of the project, especially with someone who's passionate about building a one-off car, because whenever you go down the design and development road and you come up with some really cool idea for something you can do for a client's car, regardless of what their budget is, they never don't want to do it. They always, as soon as they see something really trick they can do, they're like, well, we have to do that. The budget's going to be double, Those conversations got not awkward. They've gotten more fun. Like you can vet your client early and you can make them aware of where that can go. And it's sad sometimes when somebody's like, well, I really don't want to go down that path if it's going to be 4 times. But being prepared for that is what makes the projects fun and makes it to where they can be funded to do the fun stuff along the way.
Now, 2 aspects on this. I, looking in from the outside, and even with my own background, we build a fair few pretty much ground up drag car builds through my old business. And even after doing a handful of those, if someone came to me and said, this is the idea I've got in mind, what's it going to cost? I found that exceptionally difficult. It's kind of one of those, as the project evolves, you kind of just don't quite know where it's going to go to, even if it's something that you've done along similar lines. So I found that incredibly difficult to price a project accurately at that level. I'm interested in your take on this. Obviously, you've done this a few times now, so you've got a few runs on the board. It must get easier as you go, but how do you ballpark the cost and the time, I guess, which drives the cost of a build like your SV Rover, which we're going to talk about in a bit more detail soon?
That particular project I put so much time and money in that project, and it went well beyond. I was unwilling to compromise on anything with that one project. I'm not saying I'm willing to compromise on other clients' projects, but the point at which you say this is good enough is understanding the budget and wanting to stay within that and move the project down the road. Because it was my own project, I had unlimited time and not unlimited budget, but I was willing to throw money at it over a lot of years to get to where I wanted to be.
In fairness, I should also point out that this just doesn't just go for a full car build. I mean, we can boil this down to quoting just about any task.
For sure. The only reason I bring up the full car builds is those are the hardest and the ones where you can really get in a bad situation. So when somebody comes in, what is the thing you want to build? What are the components we know of that need to be purchased? And you build a spreadsheet. And then you say, okay, this is a ballpark idea of how much design. And as you go through the spreadsheet you're building, I start pulling up old clients' jobs that are similar. This was a truck we built this time. This is how many engineering hours we put in it. This is how many fabrication hours we put in it. Was it similar? This is going to be slightly more complicated. Let's bump that by 30%. Let's take 20% off of this. And you can start to build your spreadsheet. And off the top of your head, you would say, well, geez, if you have old projects you're dealing with and you fundamentally know the kind of things you're going to use to build this car, you should be getting pretty close right out of the gate. But once again, there's so much that you don't know until you start the project because it evolves. That's why my 2 to 4x number is important to financially prepare the client. And it's that let's not have this be a tube chassis sitting on jack stands in your garage, which I've done to a client, and there's still a car sitting on jack stands in a client's garage because of this.
I mean, there's no future in that situation for either party. Either everyone kind of ends up feeling deflated and kind of let down. So, yeah, I think those honest and frank discussions with the customer at the outset and where the budget could go and where the difficulties are in providing like a fixed price contract or something like that are critical. The other part that I'm interested in, I've faced this numerous times through my old business, and I'm going to guess that you probably have the same, so I just want to discuss it. Customer would come in, get a job quoted up, let's say is a turbo kit and an ECU or whatever it might have been. So let's say it's $10,000 worth of work, fine. And then halfway through the build, customer comes in to check on progress. Oh, I want to actually change to this wastegate. Yep, no problem. That's going to add $500 to the bill. Oh, yeah, no problem. Next week, oh, we want to change the fuel system to this. Yep, fine. That's another $2,000. And this goes on, and there's 4 or 5 additions. Each time you're saying to them, yep, it's going to be X on top of the $10,000 we originally estimated. You get to the end, and the customer at each point has accepted the additional costs, but in their mind, they're not adding it up. And I saw this so many times. You get to the end, the customer comes in, and now the $10,000 bill's blown out to $15,000. All through their own doing. Everything's been discussed. The prices have been accepted. And they're like, oh, but you quoted $10,000. Yeah, well, yeah, we did. But then if you remember, you added all of those parts, and all of those parts are another $5,000. And it was just a constant frustration for us. We went through quite a lot of work to try to fix those pain points that we see in that sort of enthusiast level performance workshop, and it was always about pricing, and it was always about sort of jobs being misquoted. And I kind of see this worldwide through the industry, and it kind of gives that performance workshop industry almost a bad reputation. So what we would do is, to the best of our ability, estimate the job. And I mean, there were some bread and butter jobs that we did day in and day out, and those we could price to the dollar. Like it was a package deal. We've done 100 of them already, so you just know what the labor, what the parts are going to be, and I could tell them to the kilowatt how much power the engine was going to produce at the end. And those jobs were seamless, unless you got to a point where, hey, your car's probably lived by the ocean for the last 5 years, all of your exhaust manifold bolts are rusted solid. I'm sorry, we're going to have to charge more because these just don't come out. And you'd have to be a pretty unreasonable customer to not accept that. With the custom stuff, we'd say okay, here's our estimate. These are all the parts that are going to go into it. Here's our best estimate of the labor. This is an estimate only. Understand that we're going to do our best to stick to this price. And if anything changes, if we get into the job and we find something that we couldn't have known about at the outset, what we're going to do is stop the job. We're going to ring you. We're going to tell you what we've found. We're going to tell you what the additional cost is likely to be. So I think it was always about communication. And that was the error that I see a lot of workshops make, is they put their head in the sand and they're like, well, I don't really want to talk to the customer and tell them it's going to cost more. At this point, we were halfway through the job, so let's just carry on and get it done. And that's almost the worst thing you can do, because now you get to the end of the job, the customer thinks everything's been sailing along as expected, and now they get a 20 or 30 or 50% increase in their price. And I think that's the bit that pisses customers off.
Yeah, 100%.
It is a very tricky one in the performance industry, and the number of times that I sort of thought to myself, You know what? I wish I was just running a franchise dealership where a car would come in for a cam belt, for argument's sake. It's got a 3-hour book time. That's what's going to be charged to the customer. The parts are a known quantity. You know that your mechanic's going to be able to do it in an hour and a half. So you're just banking an hour and a half of free labor. The reality in the performance industry is what I normally found was you quote a 5-hour job, spend 8 hours on it, and still have to charge the customer 5. So you kind of like, it's a losing battle in a lot of ways, which is why I found, and we are getting a little off track here, but that's why I found where we could make good money and keep really happy customers when we started developing performance packages. So ours primarily were around the Australian domestic market, Holden, Commodore and HSV, so basically GM, LS based V8s. And we had 3 or 4 upgrade packages which started with just a tune, then intake, exhaust and tune, headers, intake, exhaust and tune, and then a big cam. And like I say, we'd done so many of them, you knew exactly what the job was going to take. We had basically canned tunes that I could drop into most of those cars, and it would just take 5 runs on the dyno, you got it touched up. It took longer to put the car on and off the dyno than it did to tune, and everyone's happy, and we're making money.
From a business standpoint and a client standpoint, that sounds amazing, but it gets boring.
It does. It definitely does. And that's the problem, because the likes of you and me, we get into this for the challenge and the interest. And I would absolutely go stir crazy if every day of the week I was fitting headers and an exhaust to a Holden. That doesn't turn my wheels.
That's why we take the stupid jobs that lose money, because it keeps us entertained. And the bread and butter pays for a portion of our entertainment.
Definitely. The other problem we have here in New Zealand is that it's a small country. We've got, 4.5 million people. The city that I lived in and ran my shop in had 5, maybe 600,000 people in it. So it's a small city. We've got a massive range of vehicles. So if I wanted to go into business and specialise in only doing these Australian domestic market Holden Commodores, I'm probably going to get 3 or 4 jobs a week if I'm really lucky. It's not going to pay the bills. So you're kind of forced to be that jack of all trades and basically be able to deal with just about any car that a customer wants modified. And that kind of comes back to that first problem of like, okay, well, how do I quote work on a car that I've absolutely never worked on before? That brings up a whole new can of worms.
For sure. You don't know what you don't know until you, and it's like when you work on your own car and you don't have a manual, never done a particular job, you do the left-hand side, it takes you 5 hours. You do the right-hand side, it takes you 30 minutes.
Exactly. There's a meme that I quite like. It's a big sign in someone's workshop and it says, we do this not because it's easy, but because we thought it would be easy. And that's so common. I kind of remind myself of that every time I'm sort of 3 hours into that 30-minute job. All right, let's kind of catch up to current day. Let's just get a bit of an overview of what Scarbo Performance and Scarbo Vintage is, and maybe you can explain why there's 2 separate entities in there, location, size, staff for a start.
Of course. So Scarbo Performance started as an engineering consulting company. Now it is a company that does turnkey design and manufacturing, and I like to say napkin sketch to attractive. We can design it, build it, print it, machine it, fab it, assemble it, wire it. That keeps it fun, and you get to have your hands on a lot of different things. And it's kind of nice when it's nice and it's important when you're building a one-off thing to have as much done under one roof as possible, because there's so many things that are interworking with one another that somebody has to know how everything's going to go together. And it can't be a big group of people necessarily. Otherwise, it takes 5 times the amount of time and 10 times the amount of cost. A lot of clients that come to us now come to us, unfortunately for us, with crazy deadlines. And it's because we do all the stuff in-house and we have so much control that we're able to execute 5-month builds in 1 month.
Wow.
But because we do that, everyone's like, oh, hey, SEMA's in a month and a half and we need this done in a month. And it's just, SEMA's an example, but it's everything, right?
It always used to frustrate me with my old business because we were tuners. And if you're building a race car, for example, the tuning is, of course, the last hurdle before the thing can hit the racetrack. And the number of times that I had a customer who would sort of ring me 3-4 months in advance, say, hey, I've got this car, we're building it up, we've got this event that we want to make, and it's just in the final stages of fab. Can you tune it? Yeah, no problem. Get it to us XYZ date and we're good to go. And then you get a ring like 2 weeks before that. Oh, we're running a little bit behind schedule. Can we bump that a little bit? Yeah, but we're getting tight now. There was a problem with paint or whatever it might have been. And now it's 11 o'clock at night on the Friday night before their event. And all of a sudden, their lack of planning or execution, or whoever's fault it was, I don't really care. All of a sudden, it becomes my problem as the tuner. I was like, then they're getting attitude with me because I don't want to be at the workshop on the dyno at 11 o'clock at night. It's like, something's wrong here. This doesn't work.
It's the world we live in.
It is.
Deal with it and charge accordingly.
Yeah, that's sometimes easier said than done. So in terms of services, basically you've just kind of mentioned it's a full sort of napkin to turnkey car build. What sort of equipment have you actually got in-house for these builds? Are you talking in-house CNC machining? Are you sort of outworking that?
We do in-house tube bending, in-house CNC tube cutting, in-house welding, in-house CNC machining. We have a manual machine shop here in-house. 3D scanning. We have a hexagon roamer, and we have a Creaform white light scanner. CAD tools, CNC programming software.
So you're really heavily leveraging the current crop of technology that's available for sort of design and manufacture.
For the most part. We design primarily in SolidWorks. We do use Fusion as well. We do our CNC programming in Fusion 360, which for me personally, I don't have a big CNC programming background, but it's like very, very simple. We do have 3D printing in-house, but not all 3D printing. As anybody who operates in the 3D printing realm, there's lots of different types of printing for very different outcomes. So if we need to 3D print fixtures in-house or 3D print a test part, no problem. We can print it, have it ready in the morning. If we're doing something more complicated, we do not do any metal printing here. We have to outsource all our metal printing.
There's a barrier to entry in terms of price, though, for 3D metal printing, correct? I mean, you can get a reasonable quality consumer grade FDM 3D printer for, maybe under $5,000, but to get something in the metal printing sort of realm, you're probably sort of looking north of 50 grand and probably for something of a reasonable size, substantially beyond that. So I can understand that most shops are going to be outworking this, correct?
Yeah, and depending on who you outsource to, it's like they have so much more capacity than you do. If you have a big job that comes through, they can put it on 10 machines.
I think you've got to also weigh up the fact if you're going to be looking at spending, let's say, $200,000 to $500,000 on a piece of equipment, that thing's got to be earning its keep, which means that you really want that thing running as close to 24/7 as you can get it.
It's the same. We don't do in-house plate laser cutting. That's another piece of equipment that, granted, depending on what you do, you want to have a regular laser, you want to have a fiber laser, and you want to have a water jet to be able to do all the types of things you want to do.
Can you give us a quick rundown on the difference between those three and where you would use each?
Yeah, so as far as the fiber laser and a standard laser is going to be hard for me to explain. All I know is that when we outsource stuff, they choose one or the other depending on the plate thickness and the material type.
Okay, fair.
But obviously a water jet is drastically different. The water jet is a stream of high pressure water with essentially sand particles in it that is an abrasive that cuts a piece of material. The nice thing about that is you don't have a heat affected zone in a lot of areas because it's not physically melting the material, it is cutting it. But there's a trade-off to speed and accuracy and contamination.
As I understand it with the water jet, particularly when you're starting to look at thicker profiles, that you don't get a nice sharp sort of square cut. Is that correct, or am I off tangent here?
It depends on how fast you're cutting. If you cut extremely slow with a water jet, you can get a very vertical wall. But the faster you go, the water tries to find its way. I don't know off the top of my head inches per minute, but it's probably 10 times the speed. So if you're looking to make 100 brackets or something, the laser is going to rip through that thing so much faster and arguably more precise.
But long story short, you don't really need to worry about this. You send the design to whoever you're outsourcing this to. They choose the material and the equipment to suit the job, and it turns up in a week or so's time, ready to go.
We have a handful now of plate vendors that do laser cutting and CNC press braking, some that even do full welded assemblies. And depending on what we're looking to make, we know which vendor to send it to. If we have something that I need tomorrow, one of my vendors lives near me and he brings the parts home and sets them on his porch and I bring them to work. It's one of those things that has made it to where I don't need to think about having a laser at all.
I think that's sort of another example of where leveraging relationships in this industry is just so important. I'm guessing he's probably not doing that for all of his customers.
So for the most part, my business is vertically integrated. We have every process that we need to execute somebody's part. And that's how we're able to build somebody's 6 month or 5 month project in a month, is because I can say, I have this machine, let's push off that job, push off this job. I know how to like rejuggle the shop in order to get that one thing done. If there's any one part of that puzzle that you're outsourcing, you need to make sure that you have vendors you can rely on, that you know the time frame associated with getting parts from them. One of my vendors, typically speaking, a laser shop is like a 1 to 2 week lead time on something. But I'm willing to pay expedite because my clients are willing to pay expedite and they're looking to meet a deadline for a show. So if it's something where it's like, hey, we'll have files to you tomorrow and he can start cutting and bending immediately, that means that I can trust him as a vendor and I can quote jobs and lead times that correspond with what my vendors can do. But you were saying it's relationships based and you have to be a human with your vendors, right? You have to understand the pressure you're putting them under and when to push and how to push and to get the kind of response you're looking for. Because it's like you can work hard with somebody and enjoy it, or you can work hard with somebody and hate every minute of it.
I think it's sort of also a case of if you're dealing with a given vendor and literally every job you're passing on to them, you're on them like, hey, I need this tomorrow. I need it right now. Why haven't I got it? That's going to wear thin real quick. So I think it's a bit of give and take. I mean, if every 10th job you really have to apply that pressure, that probably is going to go down with that vendor a lot better than absolutely every job. Obviously, if you've got an expedited service fee, well, it sort of goes with the territory. But yeah, that's been my take on it anyway.
So yeah, it's all about knowing your vendors and being a reasonable person with them.
Definitely. In terms of your workflow, are you doing just one project at a time, or can you service multiple?
The current statistic is that I think 70% of our work is production work that's business to business for other shops, building exhaust systems and roll bars and suspension parts that are all private labeled for other shops. Years ago, we started a different business and started to develop our own parts, and we sold a couple sets of adjustable camber arms for Teslas. And the first two clients, granted, I understand people have questions and want to talk about products they buy. We spent twice as much time talking to these customers about the products we'd sold them than we did developing and building the parts. And very quickly we learned that we don't have a team of guys here answering phones, and it's not in my best interest to be discussing the install of a camber arm. Or that's when we started to realize selling batches of 30 to 100 of something to another business at wholesale, and then they have a team of...
And never having the phone ring with technical queries.
Exactly. So that's what we've been doing for the past roughly 10 years, is private labeling parts for Porsche, Tesla, primarily Porsche and Tesla, to be honest.
Yeah, I think a lot of people see the sort of dollar signs in terms of making parts and selling direct to consumer. And yeah, obviously there's more margin in that. There's more marketing challenge in it. But yeah, the part that's really easy to overlook is the amount of technical support that's going to require versus, as you say, selling a batch of 30 parts at a discounted cost, but just never having to deal with picking up the phone other than taking that order in the first place. So in terms of the production work that you're doing, I'm guessing that that's sort of a known quantity. You've got X coming in the door every month for those parts that you're selling. Does that sort of give you the flexibility with some of these bigger jobs that might take, between maybe 1 and 5 or 6 months? Obviously with those, there can be some cash flow sort of issues along the way, even if you are taking sort of progress payments. Does that sort of give you a bit more flexibility with those bigger projects?
It does, for sure. I think there's some inconsistency associated with production orders of parts from clients. It varies based on consumer demand. It's one of those things, feast or famine, always business, right? So yeah, the production stuff is definitely more consistent than building one-off cars. And I think over the years, we've found a way to be able to be profitable with obviously our production work and our one-off builds.
In terms of the challenges of actually getting the customers for these bigger jobs. How do you sort of go about that? What are you doing for marketing, or has this sort of become word of mouth? Have you kind of become one of the go-to builders for these one-off trophy truck style builds?
Everything, we've never done marketing at all. So everything is word of mouth, which has been really nice. I feel that my clients sell my business for me, and they can tell other people, their friends, kind of what that process was like. So that has been a blessing.
How about involvement with some of the bigger projects that have got a lot of sort of press exposure on social media, like the Huna Pig? Does that kind of, was there a noticeable sort of uptick in interest in working with you after that, or has that not really had too much impact?
Because of what this business does and the price point at which it does these projects means that the overall market for people who can utilize our services is relatively small. Our Pikes Peak project for 2023 with Bradford to design and build their Type 62 Pikes Peak car, that project was a referral from BBI, who we built the Huna Pegasus for. So arguably, I was going to say no, there wasn't any uptick in business after Pikes Peak in 2022, but technically speaking, there was, because we ended up with a Pikes Peak project in 2023.
Even if you get one job, it's probably been a worthwhile exercise. I guess the part of this that's probably worth understanding as well is that while, yes, the Huna Pegasus got a massive amount of social media exposure, I don't know how many multi-millionaires that actually have the required funding to build a project from the ground up like what you're doing, a kind of scrolling Instagram every day. They're probably a bit too busy for that, but maybe I'm wrong.
Yeah, I mean, there's a handful of people personally that can afford to do stuff like this, but mostly it's businesses and companies.
Yeah, I mean, it's an expensive process, and rightly so. I just wanted to take a moment out of our interview with Joe and talk about a course that I know you're going to love if you're enjoying this chat, and that is our 3D modeling and CAD for motorsport course. Normally $199. You can use the coupon code SCARBO50, that is SCARBO50. That will get you $50 off the purchase price, bring it down to just $149. Now, I know a lot of people would think that learning these skills are beyond them, but the reality is that it's actually quite straightforward, and this can massively expand the range of what you're capable of doing when you're working on your own car. We start with the basics of CAD, such as what CAD is, the various software packages available, and what you'll require in terms of computing hardware. We move into the design fundamentals, because when you are using CAD to design parts, it does help if you've got some basic understanding of engineering design principles so that you can design parts that are safe and fit for purpose. Next, we move into solid modeling basics such as datums, 2D and 3D sketching, extrudes and holes, revolves, sweeps, and piping, just to name a few. Next, we move into sheet metal modeling basics such as converting to sheet metal, bends, flanges, flat patterns, and bend back. We cover assemblies such as assembly basics and assemble joints and constraints, and then analysis such as geometry, measurements and mass, analysis tools, motion and contact analysis of assemblies. Next, we move into post-processing such as drawing fundamentals and setup, part drawing views, dimensions and tolerances, and exploded views for assembly drawings. We also cover advanced CAD topics such as surface modeling, simulation and FEA, generative design and automated modeling. And we touch on 3D scanning and printing, as these technologies are now almost hand in hand with 3D modeling and CAD. We've also broken the entire CAD process down into a 5-step process that you can apply irrespective of what part you're personally interested in producing. This makes it really easier for you to design your own parts by breaking down what on face value may seem like a daunting, complex process and into individual bite-sized steps. This course also includes a library of worked examples where you can watch that 5-step process being put to work in a real design job. So remember, the course itself, $149 when you use that coupon code SCARBO50, and you'll find the coupon code and a link to this course in the show notes. Remember that you are still protected with our 60-day no questions asked money back guarantee, and you are able to further break that payment down into as many as 8 weekly payments at the checkout. Let's get back to our chat with Joe now. All right, let's move into talking about one of the projects that you've got a fair bit of exposure for just recently. I mean, obviously, you've been instrumental in the Hoona Pig. However, I feel at this point, with now, I think either 3 or 4 podcast episodes dealing with this from the likes of Dimitri, from Sander, etc., probably we've done that to death, and I think everyone probably knows enough about the Hoona Pig. But I'm really interested to dive into your latest creation, which is, you've dubbed it the SV Rover. Now, again, if people haven't seen this, maybe we'll put a link to your tech tour of this after the ice race so people can kind of get a bit of a visual on it. But let's dive into this. What was the initial concept for this? And how did you come up with it, for that matter?
So to backpedal to the Volkswagen Touareg in 2008, that was a project that was a very short design, development, and manufacturing timeline to get ready for the Baja 1000 in 2008. So we had to basically design and build a truck in 6 months, test for 3 months, and then go race. There were a lot of things that I personally wanted to do with that project. And you had mentioned earlier about wheel design and reducing unsprung mass and how important that is for vehicle performance. And if you look at off-road things in Europe, especially cars, most of these performance things are independent suspension.
Reasoning being here that a live axle is always inevitably going to be significantly heavier in terms of the unsprung mass than independent.
And there's a lot of things you can't do with this, with the geometry of the tire contact patch per se. So for a long time, desert race Baja trucks have been two-wheel drive, solid rear axle, independent front suspension. That's how it's been. And the two things that are drawbacks, in my opinion, is the lack of four-wheel drive isn't necessarily a performance disadvantage, not much endurance desert racing, but it is a big drawback for tire longevity, because when you're off-road with a two-wheel drive truck in soft terrain, you're spinning the rear tires over every obstacle, whether it's rocks, boulders, trees, and it just tears up the rear tires. So being able to have 4 tires propel the car means that the tires can live a lot longer. Not to mention it can pull you out of a hole. Or when we raced Baja a few months ago, I had never personally been in Mexico silt. I don't know if you've heard of this before.
I have not.
So the best way that I can describe silt is it's like a cross between baby powder and sand. And you get in this stuff and it almost makes a dust cloud you can't see through, and eventually it'll go up over the windshield of the truck and you can't see anything. And because it's so soft, if you're in something two-wheel drive, you're trying to carry enough momentum to not get stuck, because not only is it extremely soft, you can't see through it, but there's usually ruts where the tires are on that specific trail. So you're trying to not get buried, not get high centered. And usually when you get to this part of the trail or the race course, there's 5 cars buried in it, where there's one car that's centered up on the main race course. There's another car with the only other trail you could possibly take that's buried to the right, another car buried to the left because he realized he couldn't go to the right. So in our early stages of testing, we were able to see that because of the tire footprint, the four-wheel drive, and the weight and the power, it's able to, we went through some sand dunes early on that typically, the sand car that I built at the tail end of high school and in college, I was always used to carrying momentum and knowing how to drive through sand to not get stuck. And when I went up this first dune, I expected to roll on the power and have a bunch of tires slip, and there was none.
Wow, just hooked up.
And it was all about flotation, four-wheel drive, weight distribution, and overall vehicle weight. So when we got to Mexico, we got to the silt. There was a four-wheel drive Bronco stuck in the silt in front of us. I think there were roughly seven cars scattered about. We pulled up behind this four-wheel drive Bronco and climbed up a 5-foot wall out of the silt to drive around the Bronco that was stuck in the silt. And it was a testament to just what that truck is and what it can do.
I can only imagine that would be pretty satisfying.
It was ridiculous. And it's one of those things that you think you're going to get stuck. You don't think it's just going to climb out and everything's going to be fine. So that was really neat. And then at the tail end of the Volkswagen project, I wanted to design something where I could implement all of these various technical aspects that I wanted to do with that project that we didn't have time for. So the Touareg was mid-engine, so that was a good start. It wasn't four-wheel drive, and it wasn't four-wheel independent. And if you've ever watched a vehicle go over large bumps at speed, depending on how fast it's going, the tire will start to skip eventually. if the bumps are large enough and if the vehicle speed is fast enough, you will end up with a percentage of tire contact over the course of a run. So at the tail end of the VW program, I started developing another desert race truck, which was going to be four-wheel independent and it was going to be mid-engine, designed around the Score trophy truck rules. As I was developing that, King of the Hammers started to become fairly popular. And in the early days of King of the Hammers, all those trucks fundamentally were solid front and rear axles. And rock crawler guys like to run solid axles for mechanical robustness. Another reason I think they do it is because the center of gravity of that axle is extremely low. There's lots of components made for that, like heavy differentials and locking differentials, etc. However, because King of the Hammers has high-speed sections, people started to want to go with independent front suspension to reduce the unsprung mass. And obviously, they start with the front. It's off-road racing in the U.S., right? You like tiptoe into the technology because people are too scared to like go all in on it.
Yeah, you're sort of in that situation with, well, this is how we've always done it and it's worked, so we'll just keep going in that same path, maybe ignoring the fact that, yes, there could quite likely be some better technologies that we could apply and try.
And that turns into decades, right? But one of the things that I did when I left Volkswagen is I made a spreadsheet that was like cycle frequencies of unsprung mass based on spring rate. So you realize quickly that the only energy that you have to push the tire back to the ground is spring. And the things that the spring are fighting is rebound valving and unsprung mass. So the thing that I think is interesting, I used to hear it from off-road guys, is they say a light truck won't work. Like the truck has to be heavy. And the thing that's interesting about them saying that a truck has to be heavy to work in the big bumps is because what they're really saying is that the sprung to unsprung mass ratio has to be X. So if you have a heavy wheel and tire and you have a heavy solid axle, you have to have a heavy sprung mass, which results in a heavy spring and a lot of energy to cycle that mass.
Makes sense.
So in order to develop a good working lightweight off-road truck, you have to start with the wheel and tire and hub package. And you have to do everything in your power to try to make that as light as possible, because otherwise you're not going to be able to cycle a wheel and tire.
This is a challenge, though, as well for this very specific type of motorsport in terms of you're wanting to produce a very light package of the unsprung weight components. But of course, these are being subjected to massive forces as well, something you'd never see in a road race application or on the street. So by definition, you're sort of walking this razor edge, I guess, of trying to balance strength and reliability or longevity with trying to keep that weight down.
That's where mechanical optimization, the wheel stuff, comes into play. It's how do we make a part that's half the weight and just as strong, if not stronger? And it takes the loads in the directions that the loads are being supplied, right? Just mechanical efficiency. That's the entirety of it. So the SV Rover has 15.5-inch Brembo carbon ceramic brakes, and it had absolutely nothing to do with stopping power. It had everything to do with taking an additional 20 pounds of unsprung mass out of the hub. That brake rotor is 13 pounds, and in steel, it's 33 pounds.
Wow, that's huge.
But unfortunately, carbon ceramic brakes don't like to stop when they're cold. And the majority of the braking scenarios in an off-road thing is stopping when it's cold, coming down a tight rock section with cold brakes. And that's not ideal. So I think that's a trade-off where we might develop a steel rotor for this truck that's lighter than usual, but has better cold stopping performance.
Yeah, always a challenge with the braking package to find something that's going to work in the temperature range that you need it to work in. I'm normally at the higher end of that spectrum in a road race application. You don't really care what it does when it's cold and you roll out of the pits. But of course, yeah, different set of criteria there that you've got to deal with. I'd be interested, you've talked already about your initial foray into RC cars, and I've watched your interview your tech tour, I should say, of the SV Rover, where you actually talk about the sort of design cues that you've taken from RC cars. So can you talk to us a little bit about that? How much did that actually drive the design direction, and what, I guess, can we learn from RC cars?
So during the original design, and I had a few mechanical things I wanted to achieve, and those things were as minimal unsprung mass as possible and a drastic rising rate motion ratio curve. And The best way to achieve those two things is with an inboard damper and a rocker, because it takes a lot of, you can decide where you want to place the loads, and you can tune your motion ratio curve to your liking, depending on what you're looking for.
Let's just stop there and I'll just define that motion ratio, because a lot of our listeners probably haven't heard that. So basically, when we're talking about a motion ratio, we're talking about the ratio between if the wheel moves 2 inches, how much does the damper move? If it's 2 inches as well, we've got a 1-to-1 ratio, but that's not always the case. And then as you're talking about here with a rocker arm, you get to tweak that to your advantage, in that the motion ratio when we start from full droop and we move the wheel up might be X, but once we're actually starting to move towards the extent of the bump travel, it might drastically change. Can you explain why that rising motion ratio is important in this application?
Of course. So I'm going to explain two things at once. First, if you think of most off-road front independent suspension, the shock is roughly halfway down the control arm. It's in between the inner pickup points and the wheel. Because it's halfway down the arm, you have roughly a 50% motion ratio, 0.5 motion ratio, which means that for every inch the tire moves, the shock is going to move half of an inch, which is what you were just explaining. Now, two things were done when we decided to go with an inboard shock and a rocker. We got a rising motion ratio curve, and we ended up with far superior structural optimization from it. That's because I always tell people, if you're going to design something that's mechanically efficient, keep everything out of bending as much as possible, because bending forces are the easiest ways to make something fail.
And you're doing exactly that by putting the damper pickup halfway along that bottom arm. It's just putting a bending force into that bottom arm.
I always joke around. I said, if I put a half-inch wood dowel in your hands and I told you to break it, how would you do it? You would put the center of the dowel over your knee and apply load on opposite ends and make it snap. And if I told you to fail that half-inch dowel in compression by pushing it into the floor, it'd be basically impossible. So that's what chassis tube triangulation and what we did with all the suspension components was taking the bending out of everything. So the outer portion of the control arm on the Rover is a billet 4130 block where the push rod mounts right out near the outer spherical bearing at the wheel, which means that the only thing the rest of the control arm is being asked to do is keep the location of that outer spherical in position, just like a conventional wishbone. And that billet structure has all been FEA optimized to take the loads that it's requiring.
I'm assuming here that you could not do that with a conventional damper mounted to that lower control arm out that far, because you wouldn't have clearance between the damper and the upright, particularly through suspension travel and steering movement.
You could potentially do it. The Rover has 30 inches of wheel travel. So if you have the damper attached out at the wheel, if the damper was vertical, you would need a 30-inch stroke shock.
Yeah, okay, fair.
And if you can't the damper over on an angle, you can start to reduce how much stroke the shock has with that angle, but it's not going to reduce it that much. So you end up with a compromise of, okay, typically speaking, all these shock manufacturers make an 18-inch stroke shock, max. That's the biggest they make. If you want 30 inches of travel, you're pretty close to your 50% motion ratio.
Yeah, okay. So it's basically drives where you can mount that on the bottom arm.
And you end up having to build a structure that's very robust with a massive bending load. At the end of the day, we typically use between 6 and 8 vertical Gs of load to run our simulations for mechanical robustness for off-road applications.
Okay.
The SV Rover was designed to a 10G vertical load for all components. And everybody looks at the lower control arm, and the first thing they say is there's absolutely no way that's going to live. It's going to break the first time you send it out, and it has the highest factor of safety of any off-road thing we've ever made.
What sort of safety factor do you apply to that?
If we designed it to the 10G number, and we're only seeing 5, we have a factor of safety of 2 built in.
Okay. Yeah, that was kind of what I was getting to. You're talking 10G. What realistically would you see as 5G, something that would be realistic under normal circumstances?
Correct. And obviously, in off-road racing, you really have to define odd things, like what is a racing incident and what is a crash? And what kind of crash do I potentially want to be able to make it through and keep going? So unlike road racing, where your load conditions are a lot easier to define.
And again, you're sort of coming down to that fine line of strength versus weight. And how big a safety factor do you want to put in? As you say, I mean, what sort of crash do you want to sort of be able to live through in terms of the chassis components, I'm meaning? Coming back to that rising rate, am I right here in guessing that this is sort of allowing the suspension to do its job really well through the lower part of its travel, but then when you get those really big hits, it ramps up the motion ratio to sort of stop you from bottoming so easily? Is that kind of my read on that right?
That's correct. And the way that everybody in off-road racing is currently doing it, because in off-road racing, you do need rising rate in one way, shape, or form. So a bypass shock is one way to do it, and an air bump is another way, or some type of bump stop that gives you a lot more load as you get towards full bump. Now, a bypass shock operates on a step function. Like if you look at the amount of force the shock is producing based on its position, every time you get past a particular bypass tube, you have a jump in damping force. The neat thing about the Rover is that you don't have to run a bypass shock because you're relying on the rising rate to do that work for you. And if you have the rising rate built into the rocker, it's not only making the damper more progressive, but it's also making the spring more progressive. So the spring's ability to support the truck at full bump goes up, and the damper's ability to take that blow at full bump goes up.
Safe to assume as well that if you kind of tested this thing and you're like, well, you know what, maybe we want a little more or a little less rising rate and that motion ratio, that's as simple as designing a new rocker.
You could design a new rocker. You were asking me earlier about if I could design and build that truck with cardboard and welder in the shop with a bunch of tubing. And honestly, I think the suspension is easily 100 iterations deep, because with a road racing car, when you have 4 inches of total wheel travel or less, the components only sweep through space so much. Like anybody that's ever designed a fender, you build a tire envelope that says this is the tire at full lock, full droop, full lock, full jounce, etc., and you end up with like this balloon bubble shaped thing. And that's your keep out zone for a fender. That's with 4 inches of wheel travel. When you have a tire cycling 30 inches of travel and a rocker that's moving through space 20 inches and tie rods that are all over the place, you end up with something that looks like there's no way I can ever design a space frame that's going to be structural and fit within all of these geometry keep outs. It's like a nightmare.
So CAD is really the only way you could design something at this level.
Yeah. With that particular scenario, I designed the truck for 10 years. If I was doing it in the shop, it would take me 30.
Yeah. I mean, this is just the advances in technology that we've seen. And again, you've really been fast to leverage those to your advantage. The CAD's all well and good, designing this entire chassis, this entire package in CAD makes a lot of sense. You can check placement of components, make sure that you've got clearance around everything. When you actually get into the kinematics of the suspension, I'm talking here about, sort of bump steer, how the toe changes during bump and rebound, particularly when we've got 30 inches of travel here, your camber curves, etc. There are other packages available for going through that. Were you using anything there, or how were you defining the kinematics and playing around with those to get them where you wanted them before you started actually manufacturing?
The first comment in regard to that is every mechanical system is a compromise in one way, shape, or form. And you have to outline what you're looking for at the beginning. And as you go through the design, you have to start to compromise in terms of what's possible based on what the limitations are of each component that has to make the system work. So there's been comments when we posted our 30 inches of wheel. First, we got a lot of feedback saying there's no way this thing has 30 inches of wheel travel.
Love the internet.
We posted a video, and then the people that are you start to read and you see that some people are more technical, and they ask, well, how much track width change is there? And fundamentally, if you have 30 inches of wheel travel, even if you make your control arms relatively long, and one thing that people pick up first is that the inner pickup points aren't that close together. But we were able to get that on the wheel hub side by having a high backspace wheel where we push the upright and all the suspension components into the wheel to get the arm length on that side. And because I knew this truck was going to be a ton of development, I didn't want to have to develop parts that didn't need to be developed, one of which was my differentials. So the truck uses conventional Ford 9-inch differential that's built with a larger ring and pinion, but fundamentally a Ford 9-inch that's built by Curry to have CV flanges on both sides. I can't change the center-to-center distance on the two inner CV joints. which means that kind of predetermines where I can put my suspension pickup points. If I wanted to move my suspension pickup points inboard, I'd have to put the CVs inside the center of the diff, which means a much more costly differential housing, something that somebody else makes that's custom. It's not an OEM part anymore. You can't find parts readily available. So I kind of chose, let's use something off the shelf, something that's known, that I can get parts for, that is available in a bunch of different ratios, and we can design around that. And I will basically, moving the suspension and upright into the wheel is a massive benefit for a lot of reasons. It protects the suspension and all the joints and the brakes, and it also makes the scrub radius proper, meaning the center axis that travels through the outer upper joint and the outer lower joint goes basically through the center of the tire contact patch, which means that any loads that the tire sees doesn't generate a big steering force in the wheel. And it doesn't load a bunch of components. You imagine if you have like a 10-inch offset between the steering axis and the tire contact patch, every time you hit a big obstacle, it puts a massive torque about the kingpin axis and tugs on the tie rods.
So basically all round positives.
For sure. Now, 30 inches of wheel travel with independent suspension, even though the track width is fairly substantial and the arms are fairly substantial, means that if you don't have negative camber at droop, you're going to end up with a drastic track width change. The angle of the control arms at droop is more than bump, which means you end up with a bigger track width change. Now, a lot of like Detroit automotive General Motors guys were very concerned with track as a function of suspension position. And you've seen, funny thing for me is old S10 pickups or GM cars end up with negative camber at full droop. And they have negative camber at full droop to keep the track width fairly similar. So that if you're driving down a road and the right tire goes into a pothole, that it doesn't try to steer the car because the track width hasn't changed. It doesn't try to pull the car one way or another. And two-wheel drive trophy trucks are able to do that. They either end up with negative camber at droop or neutral at droop to try to maintain that track width. When you have an outer CV joint that's being forced not only to handle the suspension articulation, but also the turning angle, you end up with a compound angle at full droop that has to be accommodated, and you will never make that work with that much travel if you have negative camber at droop. So that outer joint is a non-plunging fixed CV joint, which is what an outer joint has to be because the center of rotation should land on the kingpin axis. And you can get 30 inches of travel with full steering lock out of a 40-degree joint if you don't go negative camber at droop. So I think we have 2.5 degrees of positive camber at droop to get 30 inches of travel and 28 degrees of steering angle.
Okay. I was a little concerned about how a CV works with the amount of travel you've got, but obviously, as you mentioned, you can get away with it. At the limit, would there be any potential for more? I mean, I guess, do you even need more than 30 inches of travel?
The thing that's funny is every mechanical component is basically maxed out within a degree or two of its maximum. And that was just turning the screws and turning the dials and changing the clevis angles a degree at a time until everything was happy. And when you were talking about bump steer is easy to get right when the vehicle is straight because there's a single point that the inner tie rod has to be at fundamentally to make the bump steer proper. You can play with that fore aft a little bit and it'll do essentially the same thing. But when the tires start to turn, because the outer tie rod end is traveling on an arc, and typically, like if you have a rack and pinion is traveling along an axis. So you end up with a situation that you can't use a rack and pinion in a long travel off-road application because you can't get the inner tie rod position to do what you want it to do.
Yeah, that makes sense.
You'll get the bump steer absolutely perfect when the tire is straight, and as soon as you turn, it's all over the place.
Wouldn't have actually considered that. It's a good point.
Like old GM cars that have an idler and a bell crank with a crosslink, you end up having to do something like that, and you have to start to control the arc in space to make there not be bump steer when you're turning.
Okay. Yeah, I mean, the complexity here with that amount of travel, it just goes into another whole realm as opposed to the road race application, as you mentioned, with 4 inches of travel where there's just not that much variation in where the suspension pickup points are going to be. In terms of, I talked about the kinematic design and software. Was there something you were using for this specifically?
Everything was done in SolidWorks. Like I was saying earlier, it's always compromised. So typically in a road racing car, you would build X amount of anti-dive into the front end of a car to reduce front end dive. But in an off-road truck, it's more desirable to have tire recession, which means as you hit an obstacle, the tire travels not only up, but rearward slightly, which is the opposite of anti-dive. So you end up with a little bit of pro dive, which for a four-wheel drive truck does promote front end bite on throttle. And just like a road race car, the Rover has a ton of rear anti-squat because the center of gravity is high, and we're trying to counter that by not having the truck squat when you're on throttle.
Okay. In terms of the process you went through for actually manufacturing this, because it's all designed in CAD, and you've already mentioned the fact you've got bending and CNC notching equipment inside of your workshop. The bending, is that manual bending or is that CNC bending? Where I'm getting to here is basically, can you then disassemble these parts in CAD and then send them straight to your machinery and basically pop out, for all intents and purposes, a Lego kit of parts to weld together? I've simplified that dramatically, obviously.
Yes. Our bending in-house is manual bending, and we have tried to outsource our bending. And the thing that's interesting, depending on the type of tubing that you're using, like a drawn piece of tubing can vary in wall thickness, and you can have a heavier wall on one side of the tube than the other, which means that if you have a CNC program that feeds the tube into a die and calls out for X amount of bend, if the wall thickness is varying on a different lot of tube or the heat lock is different, batch to batch, you'll end up with a different bend, which means that getting a CNC to make predictable bends gets hard when you're asking for half a degree precision.
Is this sort of to do with when you're bending, and I am definitely not a roll cage bender manufacturer, but I know enough about the process to be dangerous. When you're using a manual bender, there's a degree of spring back that you get. So essentially, if you want to achieve, let's say, a 47.5 degree bend, you're actually going to purposely overbend that, understanding that it will spring back. I can't remember. It might be a degree and a half or something like that. I don't know if that sounds about right. But are you getting at there, depending on the orientation of the tube, if you're bending it with the thick side out versus the thin side in, it's going to spring back more or less?
If the guys are doing it in the shop, they will take it over to what the number is they know for that particular bend, and then they will check it after that bend has been made. And if they're under by a degree, they'll put it back in and overshoot by 1 degree. The way that we go from CAD to physical part in our shop is that we print one-to-one templates. You either print or laser cut one-to-one templates, where when you bend that first tube, you set it in a fixture and you confirm that it fits properly. And if you've ever done this personally, there's like an art to doing it, and somebody that's been doing it for 5 years, watching them do it, you can't believe how accurate they can be doing something manually.
So this is one of those rare instances where manual can perhaps be superior to CNC.
For us, I don't want to speak for all the CNC tube bending shops out there, but for us personally, because we do make production roll bars, which we still manually bend, we make production roll bars in volume of like batches of 10 to 40 at a time. And when we get order quantities of 40, it's really hard to justify bending 40 bars manually in-house. And we would start to try to outsource that. And that's when we started to learn about all of these nuances associated with the tubing and CNC bending, is that when we bend a tube in-house and we set it in a fixture, it just drops in. And when we would get tubes CNC bent in batches of 40, where they're running tubing through with the same CNC program every time, not checking every single bend, you end up having to force the tube into the fixture because each bend isn't either perfectly placed or it's not perfectly the correct angle.
It's really interesting to hear, because I think just with my level of exposure to this sort of equipment, which is relatively limited, you hear the term CNC and just expect perfection. So it's interesting to hear that there are still nuances to this.
It's probably been 2 years since we've done it, our last go around, when we decided it's not a process for us. And I don't know if it was our vendor or everything that he was expressing were the hurdles associated with CNC bending make sense. And I don't know how you would... A CNC is made to do the same exact thing over and over and over again. But if there's a variable associated with the material you're feeding into the machine, it's hard to get that program to do the same thing over and over again.
Yeah, okay. All right. On the same note, sort of when it comes to actually welding all of these tubes together, obviously they need to be held in the correct orientation to make sure that you don't end up with a situation where it you get to the end and the bars don't fit anymore, the tubes don't fit anymore, or heaven forbid you end up with a twist in the chassis. What are you doing in terms of fixtures to hold everything in place while the construction is going ahead, taking everything together, final welding it, etc.? And how are you producing those?
Of course. So our smaller weldments, we have primarily 4 welding stations in the shop, all TIG welding stations. We have 3-foot by 5-foot fixture tables that we make. They're laser cut plate, but we weld them in-house, and they're within a 0.5 millimeter flat, which is tight tolerance for the fab components we make. If we're making something small, we have welding benches for that are gridded out on a pattern where you bolt laser cut fixtures down to them that hold any critical machine bosses or any saddle locations with hold down clamps for tubing. We have one fixture table in the shop that's roughly 8 feet by 12 feet long, and that's the table that we build full chassis on. And they're built in the same way, where you have a laser cut fixture, picks up all the hard points, it has saddles to place the tubes. And the first time you do this, if like I was mentioning, it's years and years of hand fabrication and notching stuff on a sander or in a bandsaw, and you can fight a tube for an hour getting the proper fish mount, and you walk up and finally it fits perfectly. When you notch with a CNC, you walk up, you set the tube in, and it fits perfect. It's like cheating, but it's very satisfying to have the fit that you're looking for right out of the computer.
And that fit up, of course, is so critical when you're TIG welding. There's you don't have a lot of room to hide poor fit up, do you?
Correct. If you're TIG welding, the fit has to be really good. And second, if you're wanting to be profitable with a job, you can't be spending an hour on a notch.
Yeah. In terms of material, what are you using here? Is this chromoly for the actual tube frame?
We use chromoly only for heat-treated suspension components. We use DOM tubing or DOCOL for chassis parts.
Is this due to the problems you get around chromoly with the heat-affected zone around the welds and it becoming brittle?
Exactly.
But you can get around that with a component like a suspension arm that's fabricated out of chromoly and welded properly. Then you can heat treat it, which essentially stress relieves the component and you don't have that problem with it being brittle, correct?
Correct. And the thing that's interesting about 4130 tubing is that 4130 tubing, as it comes from the mill in normalized condition, has a yield strength around 68,000 psi. Mild steel tubing is closer to 55,000 psi, which isn't, everyone would say, wow, that's a big percentage increase, but it's not. In my opinion, it's not big enough to justify the other associated issues that come from it. If you heat treat a suspension component, you take that yield strength from 68,000 psi, you could take it up to 130, 140,000 psi, which is, like a leaf spring or something that has a lot of elastic deformation before yield. So if you're making a small part that you can heat treat and post machine, it makes sense to make it in 4130.
My understanding, again, I'm not a fabricator nor a metallurgist, but DOCOL, which I think here in New Zealand we really struggle to get hold of, that has, for all intents and purposes, really similar mechanical strength properties to 4130 anyway, but doesn't suffer the problems with becoming brittle around the heat-affected zone. Am I on the right track there?
I have been wanting to do my own independent testing on DOCOL. I had clients that have requested we build their components in it, and we've done so. DOCOL is a seam welded tube versus a seamless drawn piece of tubing. For that reason, unlike drawn tubing, you can rely on the wall thickness being very consistent because it's generated from a piece of sheet. But the strength numbers that they advertise for DOCOL don't necessarily equate to me personally.
Okay.
And if they're stating that DOCOL R8 has a yield strength of 100,000 psi, but the majority of the people that are welding it with mild steel rod that has a yield strength of 60,000 psi, it's hard to justify the strength.
It's only going to be as strong as the weakest link, essentially.
Yeah, exactly. So there's fundamentally 2 different welding rods that we use in the shop, which is ER70 and ER80. ER70 is a mild steel rod that we use for non-heat treated components, and it basically has the same yield strength as the DOM tubing we're using. ER80 is an alloy rod that we use for heat-treated parts that gets up to hardness just like the 4130 will through heat treat. So if you're looking for something uniform and non-heat treated, DOM and mild steel rod gives you a product that doesn't have heat-affected zone that's brittle in areas, and it will deform and bend and do what it's supposed to do when it needs to do that without failure.
Yeah, I think that's one of the things that from the outside is really easy to overlook the importance of. But yeah, like you just said, it sort of becomes a case of the weakest link is going to be your point of failure. So obviously it's critical to make sure that you are using the right welding rod for the material you're welding.
So the company that distributes GoCall in the US is AED Metal Products. And they say on their website, the spec calls for ER80 filler material, but ER70 is also suitable for both TIG and MIG.
So the ER70, as you mentioned, is essentially the mild steel with a low strength. You can still use that. I guess, I mean, in terms of welding, yes, you could weld it, but if you're relying on the strength of the material, might be not your best bet.
So it says that ER70 has a yield strength of 65,000 psi. So if they're saying to weld it with ER80, ER80 is alloy welding rod. So it's going to have a heat affected zone with areas that are brittle.
Interesting. Okay, so there's a lot of complexities in this, the material choice, the welding method, etc. Not quite as cut and dried as maybe I thought.
There's other companies that are looking to produce tubing. Plymouth Tube Company had a prototype material. When I was talking about doing this independent testing, we were going to get samples from a number of different tubing companies that we were going to weld in different manners, heat treat in different manners, not heat treat, and do test to failure samples and see how they fail and at what load value they fail.
Yeah, that'd be super interesting to see.
It would spill the beans on what's marketing and what's real.
Yeah. Well, I think most fabricators probably just sort of blindly trust what the manufacturer is saying and probably don't give it too much more thought. And the reality is that in most cases, particularly for a road race application, we're generally talking about roll cage manufacturing. And, you know, hopefully we go through the life of the car never testing that roll structure. And then in most instances, a light or even a moderate rollover is probably not going to stress the cage enough to really find its failure point. And it's only in those very extreme crashes where you find out if that cage actually is strong enough for the job.
But the thing that's funny is in a real hard crash, do you want your cage to remain perfectly rigid or do you want it to absorb some energy?
It's a great point. Yeah.
And the other thing I've noticed is that if you're building a chassis that you're requiring ultimate rigidity, the triangulation nodes, all the tubes intersect at the same node because that's the most structurally rigid way to do things. I have seen more and more OEM motorsport cages that do not have intersecting nodes, like points of convergence for tubes, which is intentional for deformation.
Yeah, that's getting to a whole nother level where you're starting to model what the cage is going to do in a serious impact and how you can design it to purposely deform in order to help protect the occupants better.
All the more reason mild steel tube.
Okay. We're probably getting a little bit beyond the scope of our podcast there. As I say, I'm definitely not a metallurgist, but it's an interesting thought process to go through anyway. I'm interested just to talk a little bit about the engine combination you've got in the Rover. At the moment, you're ICE, but as I understand it, it's also built with the intention to be able to take EV as an option. So yeah, talk us through, first of all, I can only imagine that designing the whole package around either option created some more complexities. Why do that? EV at the moment sort of, obviously there's some issues around range, particularly for a race application. And yeah, at the moment with the internal combustion engine, what exactly is it?
The engine that's in the prototype is a GM LT4, which is a supercharged 6.2, and it has the GM 8L90 8-speed automatic. The key point in designing it for two drivetrains was designing with a fully divorced transfer case, which means that the truck uses a two-wheel drive transmission with a U-joint output that has a short shaft that runs to the transfer case. If we choose to build an EV version, it was designed to have a single motor that utilizes the transfer case ratios properly to be able to retrofit without changing any gear ratios. The entire drivetrain can stay the same with the exception of the transmission and engine. That goes away and an electric motor takes its place. And there's plenty of package volume for the motor. The thing that's hard is that 65 gallons of fuel for an off-road desert race truck sounds like a lot, but most people are running substantially more than that, up towards 100 gallons. And even at 100 gallons of volume, that's really not enough for a substantial EV range. So our truck runs two saddle fuel cells that run underneath the floor, which we did that for a few reasons. It was the approach and departure angles. Trophy trucks typically have a fuel cell in the rear that they fill. I personally didn't like that, one, because of the departure angle, and two, because as you burn off fuel, it drastically changes the weight distribution of the truck. By having the fuel centered and low, the center of mass of the fuel is in a good spot, and as it burns off, you don't change your weight distribution. And that was a good place to be able to put batteries. So the EV world is changing so rapidly, just from my perspective. When I originally decided I wanted to be able to run both drivetrains, there were so many different EV motor suppliers and various levels of people doing battery development in the aftermarket, and that has kind of changed a little bit. There still are other motor options available, but from the work we've done recently, utilizing Tesla batteries or some other OEM offshoot battery that's custom packaged just turns into the most cost-effective thing you can do for low volume, because it costs so much money to produce a battery pack that you couldn't feasibly do it with a low volume.
Yeah, no, that makes sense. And I think the whole EV sort of landscape is changing quite rapidly, and I mean it's only going to take that next generation of battery technology probably to change it dramatically again. So it's sort of, I kind of see it as a bit of a case of watch this space. I'm really interested to see how it continues to progress, because it has moved so rapidly just in the last sort of 5 or 8 years even. So the outcome with this truck, I'm interested, once we've kind of glossed over the details here, but I've sort of gone into it as much as we can without sort of kidnapping you for the next sort of 5 or 6 hours. I'm interested, like, how did it actually pan out when you got it out in the real world and started testing it? Did it just work, or did you find any sort of obvious glaring problems that needed to be readdressed?
So out of the box, it worked. The things that we needed to change immediately, first thing was the shock valving, because the motion ratio change is really good. But because of the motion ratio change, depending on the truck has air suspension, so you can control the ride height. And because the motion ratio changes as you change ride height, means that depending on where you're asking the truck to be, the motion ratio is drastically different, which means that in order for the shock to do its job at a particular ride height, it ended up needing a lot more valving than you would expect. But what that means is that if you add that valving and the truck rides adequately where it's supposed to, when it goes up to full bump, it's going to be very stiff, which is what you're looking for anyway. It's just no shock builder that I know of has ever built a shock for a application quite like this. So it was kind of a wag as to what's going to be correct. So the first thing we noticed when we went out is that the valving had to be increased drastically. The other thing is that when the shocks were built, there's small bleed screws in the piston, which allows for a little bit of fluid bypass, which makes the tire kind of like want to float over small chop. It makes the ride a lot better. But because of the motion ratio, that small bleed ended up becoming a lot of tire movement, and we had to eliminate those bleeds to get the tire dribble out of the truck, meaning with small chop, the tire would just kind of float because there was no valving control for those small positional changes. So increase the valving a bunch, eliminate the bleeds. The rear drive shaft needed attention, because when we did the Volkswagen project, I got to dive into the details of how to use U-joints properly and the sine wave that's generated from a U-joint when it's put at an angle, and how you cancel those out or make them manageable. And because the drive line had to dive around the transmission to the rear end, even though I optimally positioned the yokes, we ended up with a weird scenario where the weight of the rear drive line itself changing speed would take up the backlash in the gear set in the transfer case. And when you were on throttle, you didn't hear any noise, no vibration, nothing. But as soon as the driveline was spinning and unloaded, you would hear it take up the backlash, and it sounded like somebody had a hammer inside the transfer case, off throttle. And I was hoping to use U-joints because they're robust and simple and easy to replace, but we ended up having to replace that whole rear driveline section with CV joints. It was hard for me to find the donor components to do this, but eventually we were able to do that. So the other thing we ended up adding droop straps. And I've never been a big fan of limit straps. I think they're kind of a funny thing that's not very predictable, because a strap can stretch and a strap kind of floats around amongst all the other suspension stuff. And to me, it seemed like a robust thing to have on the truck. But in the Volkswagen days, we built our own hydraulic droop stop, which was inside the shock. And it was like a series of Belleville washers that obviously had surrounded by fluid. And when the piston would hit those at the bottom, it would have a spring force and it'd have to push all the fluid out, and it was like a cushion. Because of the air suspension, the way the air suspension works, it's like having a massively long spring, which there's a ton of nuances associated with airbags and accumulator volumes and the way that they work and the effective spring rates. But when you end up with a soft spring rate, you end up with a ton of force at full droop. And when you have a big force at full droop, it tries to push the piston off the end of the shaft. And the only thing retaining the piston on the shaft is the nut. The truck had such fast rebound, which was a byproduct of the air suspension and the minimal unsprung mass, that when it would come off the ground and extend the wheels, it had such a massive force, it was trying to peel the piston over the top of the nut. And we were seeing deformation in the piston.
Yeah, that could end pretty badly.
If it pulled the nut off, it would limit out the CV and it would blow the suspension components apart. It would be a bad scenario. So we ended up putting limit straps on the truck.
Relatively minor, I would have said.
Relatively minor. I think we can use... there's another funny caveat, is we learned this in Mexico. We did the Mexico race to do development on the truck. I didn't think we'd have the issues that we had, but we realized that we could probably use a little bit more cooling. The truck has a fully enclosed cab with a windshield and windshield wipers, which is very not like a trophy truck. Under 80 miles an hour, the truck seems to cool perfectly fine. Above 80 miles an hour, my theory is that the airflow coming up the windshield, there's scoops that go to the radiators that are behind the cab. And I think I even put a louver like 5 inches off the front of the windshield that redirects the air coming up the windshield and into the scoops. And at over 80 miles an hour, the airflow goes over the top of the scoops and it basically stops getting cold air to the radiators. So I think what I'm going to do, not that I need to make the truck any more complex than it already is, but I'm going to make a 2-piece scoop that has electric actuators that above 80 miles an hour, the electric actuators push the scoops up like another 8 or 10 inches to draw air into the radiators.
It's amazing the things you learn about what airflow actually does over a chassis at speed. We had a very similar situation with our endurance race car, which has it's a front-mounted radiator and it exits out through the top of the bonnet or the hood as you'd call it. And that was fine, but we found that particularly once we started turning the power level up, it just wouldn't stay cool. And we actually ended up doing some testing because on paper the radiator sizing, the ducting, everything was more than adequate for the power levels we're at. So we ended up doing some real sort of backyard testing at a racetrack where we just put wool tufts all over the front bar and the bonnet leading up to and past this duct. And you could straight away see that the air just wasn't, basically the airflow over the hood was preventing the air escaping from that vent. And the solution to that was we just put a little gurney flap along the front edge of the duct on the hood, and that it projected upwards maybe half an inch. That was all, and that was enough. It just transformed the cooling. So it's often, you go into these things. There was a slight hump. The duct that we used was actually a production. I think it was a VW Motorsport TCR bonnet duct. So it was made for the purpose. It had a little sort of ridge on it, but obviously in our application just wasn't sufficient. So at the end of the day, sometimes testing is simply required.
That's wild, and the fact that you can remedy that issue with a small little piece of material.
Yeah.
It's awesome.
If someone had told me that was going to solve our problem, I would have laughed at them, but yeah, here we are. So in terms of the state of the SV Rover at this point, what's the next step? Is this going to be something you're offering to customers? Give us the rundown.
Yeah, we are still, in my eyes, in the middle of development. It's something that we are looking to sell at this moment privately. We're not selling the prototype truck. I'll hang on to the development truck. It has various level of development vehicle, But yes, we are talking to a few people about sales, and it will be built with a full Alcantara interior, and it has air conditioning and a big iPad Pro in the middle of the dash, which doesn't sound very OEM, but it accomplishes a lot of the things we were looking for inside the truck. And yeah, it's I call it a hyper truck only because I don't know of anything like it that exists currently.
I mean, I'm not deep in this world, but I'd have to agree. I haven't seen anything that sort of comes close to it myself.
Somebody made a message. I don't read messages anymore. I'm fairly new to YouTube, and I realized that the amount of comments that come through on those videos is excessive.
It could be a full-time job.
Yeah, it could be a full-time job. So one of the comments was, haven't you seen the Bowler Wildcat? And I am familiar with Bowler, and very cool Land Rovers that have been raced. I just don't know if they're quite to the same spec.
Oh, it'll be very interesting to see if you can get some customers lined up and get a few of these into production. All right, Joe, look, we've gone pretty long on this one, and it has been super interesting, but I think we'll move towards wrapping this up. And, of course, we've got the same 3 questions we ask all of our guests. And the first of those is, what's next in the future for you and Scarbo Performance?
Despite what I had mentioned about dealing with customers earlier, we are working on developing our own retail components for on and off-road both. I currently have a business called Apogee Off-Road that sells primarily Toyota Overland products, which we are expanding to include the new Bronco and the Rivian. I have another business we're starting that's going to be doing high-performance, like motorsport parts for other road-going cars. But as far as the vehicle development, we've done the SBF1, we've done the SBRSR, and the Rover. I do want to do a hypercar here very soon. So it would be carbon monocoque and mid-engine V12, carbon-bodied but looks vintage.
I love turbos. I love turbo technology, but there's nothing quite like a high-revving, naturally aspirated V10 or V12. You just cannot beat that. I mean, just listening to everything you just spilled off there, I've sort of got to ask, when do you find time to sleep? That's a fairly full schedule.
Lately, it's wake up in the morning, make a list of things you want to get done. You get the most urgent ones finished, and you move the rest to the following day. I have kids at home, so I have to get home at a reasonable time. And we just moved locations. We moved into 3 times the space that we were in previously, which is really nice. But like anybody that's has a lot of stuff and moves, you move and you realize you just completely filled a new spot that's 3 times the size of the old spot, and it's filled to the gills with the same stuff you had. So I don't know how that's possible. But yeah, as far as the business goes, our primary website for the parts company is Scarbo Performance. That's the design and manufacturing of parts. And then Scarbo Vintage is a separate site that really is just for the cars we build.
Yeah, okay. Okay, our next question, is there any advice you give to a younger version of yourself to help fast track where you've got to in your career? I mean, listening to your story, it seems like it's been a sort of a series of fortunate accidents, really, in terms of the way you've kind of got to where you've got to. But yeah, I'm keen to hear, do you have any feedback on that?
Yeah, I think that stuff that I was interested in as a kid that kind of allowed me to hit the ground running when I made these connections, I attribute all of that to RC cars. It's the mechanical familiarity you get of what the components are and what they do and how the geometry works, and assembling something with your hands that, whether it's, an RC car or a full-size car, the fundamentals are essentially the same. And if you can get that familiarity young, you're leaps and bounds ahead.
Yeah, couldn't agree more. I mean, I think it's that whole mentality of what you're exposed to in your youth. I mean, be it Lego or RC cars, I mean, it just drives your sort of understanding and development. And I mean, here you are essentially just building full-size RC cars with a whole bunch more zeros on the price tag. All right, you kind of answered part of our final question, which is if people want to follow you and see what you're up to, how should they do that? So you mentioned your websites, social media as well. Anything else we can look at?
Yeah, Instagram's the same. It's Scarbo Performance, and then Scarbo Vintage, just like the websites.
And as usual, our listeners can find those in the show notes to make it easy to find. Look, Joe, it's been a pleasure having a chat with you and getting the insight into your projects and your business. It's pretty wild what you're creating, and I take my hat off to you. It's been a privilege to get that insight, so thank you for your time today.
Thank you. I appreciate it.
If you enjoyed this episode of Tuna, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Adam Jervis from New Zealand, who has said, "Awesome podcast. I'm not in the automotive industry, but have always loved and been interested in all things cars, and I'm really loving the information and I'm learning heaps. Cheers." Well, great to hear that you're enjoying the podcast, Adam, and if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.